Hey, Walter Sorrells back with another Folder Friday. Today I'm going to be showing the making of this little lock face gauge right here. So like I said, today I'm going to be showing the making of this little tool that I just made, a little lock face gauge, and it's used to measure the face of the lock on my new Mark II X model folder. Now normally when I do a build, I show you the whole thing in excruciating detail, so if you want to make it, you can follow along with me and do it yourself. In this case though, I'm really focusing more on why I wanted to make the tool and what it tells you about making folding knives, more than how to actually make the tool itself. I'll show that later, but not in super duper detail. So those of you who follow what I do with my Tactics Armory line of knives may know that I've been promising an updated version of my X model folder for quite some time, and that's this right here. I'll actually have knives for sale on the website this week, I hope. Can't promise how long they'll stay there before the first run sells out, but they should be there. Anyway, this little gauge that I'm going to show you gives you an understanding of why these knives take so freaking long to make. There's just a lot of stuff involved in kind of ramping up a folder. Way more complicated than making fixed blades, not even close. So anyway, my new folding knife, the X Mark II folder, is a liner lock design. That's this right here. And one of the most crucial items in building a liner lock is the lock face. That's this tiny little incline right here in the back of the blade. It has to mate perfectly with the lock bar, which basically jams it into place so that the knife is locked and it won't collapse on your fingers and chop you all up. So once it gets into that lock position, you can hammer on the back of it and it's not going to fold up and chop up your fingers. You make the lock face by grinding it on a belt grinder. The difference between not enough grinding and too much grinding is really a matter of about 1/1000th of an inch or so. To avoid scrapping knives right and left, this has to be ground very slowly and carefully. So kind of the classic way of making this work is tri-fitting. So you grind that little face, it's on an incline, and you test it out, assemble the whole thing, and then it's not going to be perfect the first time, and so you'll go back, you'll grind it a little more, and then you tri-fit, assemble the whole thing, then back, assemble, and you just go back and forth until you get it right. You sort of have to creep up on it, otherwise you might overshoot. If you overshoot, the lock bar will go all the way to the far side of the lock, and you'll get play in the lock, and while it will actually stay locked, you don't want the thing rattling and clicking, so you got to go very carefully. So aside from the absurd amount of time that's involved in doing this process, there are a lot of little bitty screws involved, and if you over torque one of them when you're reassembling it for the umpteenth time, you'll strip something and then you're back to the parts bin. So with a lot of these parts being made from expensive materials like titanium, that's really not something you want to do too often. Ultimately, I decided I needed a gauge that I could use to avoid all this assembly, disassembly, tri-fitting nonsense, and so this little sucker right here is what I came up with. Now, I'm sure there are plenty of other people who've made similar gauges. I'm not going to claim that this is the revolutionary design or anything. In fact, there's a thing called a Rupel gauge, which some people are familiar with, that's kind of similar. It's used for a different purpose. It's used on lock blade, top lock type lock blades. But similar idea. Now look, there are probably only about 10 people who will ever watch this and want to make this thing. So I'll put plans for it on my Patreon page, but I'm not going to bore you with a huge amount of detail about how it's made. Anyway, the basic idea is that you have a tenths gauge, meaning a gauge that measures to the 10,000th of an inch, which is less than 1/10 the thickness of a human hair, or about 2 microns. So after setting and zeroing the gauge against a machinist's parallel, you're ready to measure. The blade gets slid onto a pin through its pivot hole, then the plunger of the gauge engages with the face of the lock face, and that returns a number. Because of the way this is designed, whatever that number is, that value will allow me to know the linear dimension between the lock face and the center of the pivot. And that's this critical distance that always has to be right or the lock won't work. Now, I just finished making this thing, haven't used it enough to figure out exactly what the distance is going to need to be, what the tolerances involved will be. I have some theoretical numbers based on the plans that I've done, in Fusion 360, but theory never quite holds up in practice, so it may be that variations in the way that the lock bar is machined will mean that I won't be able to get 100%, to the correct grind on my first try using this gauge, but I'm entirely confident that it'll get me a hell of a lot closer than where I am right now with all this tri-fitting. Okay, so if you're nerdy enough to stick with me this far, you may be in for hanging in there as I make the final push and manufacture the thing. So we'll go over and jump over to the Tormach and I'll mill out the parts. I start with 2 hunks of aluminum stock, which I trim and mill roughly to size. First, I'll mill the gauge mount. Pretty simple, couple holes and then hogging off the extra material. After that, the base plate. Again, 2 holes for the pins and a little angled slot which gives clearance for the business end of the gauge and access for the parallel that I use to set the 0. The face of that slot, if you're curious, is 200 thousandths from the center of the pivot. So by adding that to whatever value the gauge returns, I'll know precisely how far the lock face is from the pivot, and that's that critical number. So a few holes are drilled and tapped for the assembly screws and the gauge set screw. You may notice I've also made a minor change from the plans. I included a pair of standoffs in the final version that sit between the gauge mount and the main base plate. This way, if I want to use this on another blade that has a really different geometry, I can add or subtract some distance by putting in a different size standoff. Same goes for if I want to change gauges. In fact, I know that I'm not going to be using this gauge in the final version of this. I'm going to swap it out for another one. So the overall message here, backing away from the specifics of this little project and how it's made, is that making production folders is not for people who like quick results. As you can imagine, making a gauge like this really takes a fair amount of effort. And that's just one example of many, many things, different kinds of fixtures and gauges and testing equipment and so forth that you have to do every step of the way if you want to turn out something that can be produced in quantity. If you're going to make one-off folders, every single one of them is made kind of from scratch, and you're doing each little bit of it in the moment, that's its own kind of process. What I'm trying to do here is have repeatable processes that I can produce a bunch of these in volume. A lot more complicated than I ever thought it was going to be. Anyway, like I said, I should have some folders available on the website in the next week or so. TacticsArmory.com. Check it out. Thanks for watching, guys. If you feel like you got something out of this video, don't forget to subscribe. Also, click on the link to Patreon for a great way to give back to the channel. Plus, check me out on Instagram, Facebook, Twitter. Links in the description. If you want something sharp and pointy, maybe a gift for yourself or one of the cooler people in your life, check out my Tactics Armory website and pick up one of our tactical or outdoor knives. And finally, if you want to learn to make Hamones or Japanese swords, check out WalterSorrellsBlades.com, where you can find videos about how I make Hamones, as well as forging, mounting, polishing, and fittings for Japanese swords. Thanks, and see you soon.